Hi guys, I just want to go through the investigation as a starting point. So keeping in mind with this investigation, the key idea of what we're trying to do is we're trying to prove that a exponential graph y equals ab to the power of x behaves differently for different values of a and b. Alright, so and we've already talked about this in class where there are two types of functions. There's growth functions and there are also decay functions. Alright, so this is what you're investigating, and you're investigating these values of a and b for this particular investigation. Now, as I showed you before, I've sort of talked through this example of how you might want to start it, and then I've got maybe the next section might be to complete this investigation, the following models will be considered. Okay, and then you can talk about which ones are practical. So I'm practical investigation using video point. This one here is a practical investigation using data loggers. So each of these models will be investigated using data to plot these in Excel and then find the equation of the line of best fit, which can then be used to predict what might happen in the long term. Alright, so that's what we are really trying to do when we are starting to look at this particular program. Now, obviously from your initial data that you got from your video point, so I think most of you should have got to this point here. Now if you do a graph of this data here in Excel, so it's just a matter of highlighting the data, going to insert a scatter plot, and we might do one with the lines there. Now you notice that the equation is upside down, which is not really what we want to do. So our graph is actually doing that, keeping in mind that we are using the x values because our videos are all sideways. Alright, so what you need to do here is you need to use this last value, 3.4432. So if we do equals for equation equals 4.33, what was it? Sorry, 3.4432. So 4.4432, take away this particular value, that's the height, and enter, and then we fill that down. If we copy that down, then we should be able to get a different sort of result. Now if I highlight that there and hold my control button down, alright, and drag that cell down there, and then I go to insert a scatter graph, then that's what I'm looking for. And I might even change that graph. So if I just change the graph style to one which has got the lines on it, you can see that's the sort of graph that we're getting here. Alright, so remember to delete that, we go to over here, and then you can do the basketball as a title. So type in basketball. Over here you can talk about that over there being the height, and we got that in meters. Enter. Just click in the cell over here, and then that's the time, and that's going to be in seconds. Alright, so that's my graph over here. Now the important thing over here is what we'd like to do is we like to just look at the maximum height, because that's the bit that falls down as an exponential. So what I need to do is go to my data, and then I can just go equals that cell there, enter. Alright, scroll down till you find the next maximum, so that would be this point here, so that's equal to that cell there, enter. Scrolling down a little bit further so you notice the data gets bigger again, so that's my next maximum, so that's equal to that there. Scrolling down 0.8 is equal to that cell there. Alright, and then doing the same sort of thing again, so I think that one there equals. So it's just a matter of working down rather than saving yourself some time. Now those particular values you could put into your table, and I'll show you what mine looks like in a second when I do that. So going to there, that's the data I actually want to plot. So if I highlight that data, and again if I go and hold control button down, I can go and find my, I've just made it bigger, I can highlight my time, and then I can insert my graph. Insert a scatter graph. Alright, and I'll just make that a little bit smaller so you can see the whole thing. Alright, so back to what we were originally doing. Alright, so again, if we select that one up there, that will give you a chart to do the idea of the basketball. Now, again, on here, on our axes, we need to highlight what these things are. So that's the height in meters, enter. That is my title, that's my time in seconds. And the title chart would be basketball. Right, so that's there, so I can delete that series, I don't really need that. Now if I click on those buttons using my left hand mouse button, right, and then right click, I can go add a trend line. Now I don't want to add want to do a exponential one, and then I want to display my values, my equation on the chart and my R squared value. And if I go close, then that will actually put a line of best fit through that data, and it'll also give me an equation which is got the value there, and it's using that exponential button there. I'll just open my calculator so I can show you how to change them on the calculator. Let's coming back to this thing. So this is a model of my particular data. Now I can make it bigger if I want to. Alright, so I can see that. You can probably change the format of this thing here, so you can actually do format the trend line, so you can actually make it a bit another color, or you can make the style of it a bit thicker so it stands out a bit more. Alright, and we can change the color and make that maybe a bright red. Alright, or make it blue, because this is blue anyway. Alright, so didn't make it a lot thicker. I might need to make that a little bit thicker so it stands out a bit more. Alright, so you can play around with that if you want to yourself. You don't have to, but I think it just makes it probably look a little bit fancy if you do that. Now, the secret is to copy that, and we can paste that into our Word document. So if we come into our document where we've got all our data, so I've put in that particular document, I've put the table, that information to the table. I know you can do that. And so therefore I can actually paste in my information there. So that's my basketball information. Now the secret here is if you go to text wrap and go tight, then you can sort of fit it to the right size and make it look like it should belong. And then you can also resize the shape of that if you need to make it fit in there. Alright, so there's some things that you can do to play around with your formatting in there of this particular graph. Now the interesting thing is, if we look at that, e to the negative 0.224, if I actually work that out, so I have to go to my E button, right? So my E button's on this ln button, so I go second function EE. So if I go, and the value was, in terms of our calculation, was negative 0.224, so negative 0.224, enter, that gives me a value of 0.7993. So what I could do is I could actually rewrite that model as equal to, and I think you need to do that with this equation. Alright, so I can write that model as 3.8762 bracket 0.799 okay, to the power of x. Alright, so that's the sort of model that I'd like to work with. Now, you notice with this model, because it's a decay function, that the value of inside the bracket here, which is to the power, is in fact between 0 and 1. And that's what we're expecting to see, isn't it? So you can talk about that in a bit of detail regarding that information. Alright, so what I've been through here is we've got an idea about how to use our Excel to get our graphs. Now, I would possibly also, in terms of my explanation about what I'm doing, is I'd copy and paste this one also into my document as well. Okay, so this would be looking at my original data. Alright, so I might show you from my video, this is what I got, and then you can talk about the process that you were looking at these maximum values. So you did that, put them into the table, did your next graph, and then you found your model based on this information here. Alright, so that's a good idea. Now, some of you may also want to consider another model. All right, so let's have a look at that idea. And this is something you need to explore in this particular investigation. Now, the easiest thing is I've already got the data that I want to deal with. So if I copy that and I paste that somewhere else inside Excel, what I can do is I can delete all that formatting. So I can delete my line of best fit, go over here, press delete. Now, if I then click on my data again and right click, I can add a trend line. Now, I might think a linear model. No, I don't think a linear model is the one, but I might think a polynomial, and we might go polynomial degree 2, so it becomes a quadratic. All right, so if I display my R squared value and over here and go enter, okay, again, I've got the same sort of thing. Now, my correlation coefficient 0.9989 is very good. All right, it's actually even better than the one I had for my exponentials. All right, so we could talk about that actually being the model, and it fits really well for this particular data, as long as I'm only looking at the range from say 0 to about 7 or 8 seconds. Okay, as soon as I go past that point there, because we know it's got a power of 2, we know that the function has one turning point, and you can see this particular graph going down to a minimum here, and then it's going to start increasing, which we know is not possible when we start looking at a basketball. It's not going to gain energy after it's actually got bounced to a lowest point and say it's rolling on the ground. Alright, so there's a danger with that model and some of the other models that we'll look at if we start extrapolating it past the point. Alright, so I'll just show you how that might work in terms of if I want to extrapolate that data. If I delete that again, let's click on our data and we go to our add a trend line. Alright, so we're going to go, we'll make it a polynomial 2. Now let's forward that, say, to the 16-second mark. Alright, and we'll display our R squared value and all that. Okay, so you can see what I'm talking about in terms of my model. So it's perfect for this data here, great correlation, but then it's suggesting that my model will start to increase once I get past that point. And we know that that's actually physically impossible. Okay, basketballs don't just bounce themselves. So there's a danger with some of our models, and you need to be aware of that when you start looking at your thing, your information that you're looking at. So let's go back to our spreadsheet. Back to our Word document. So we've got our introduction. We've explained the process of what we've done, showing pictures maybe of how we did it. We've now got our first bit of data here, which is our basketball data. We now come down, we've taken that information, we'll put it into a table. We've now got a model that we can actually use. We should write this model here in the form of a b to the power of things. So write that in that form, but also in the other form. And now you're in a situation to talk about that being a decay function. All right, so that obviously I would be doing a little bit of feedback here. You've got a couple questions to answer about what will happen to the what will be the time when it's 50% of its original height. So that's something else that you need to do as well in terms of this question. Now, the original height is in fact that, isn't it? Alright, so if we were going to do that type of question, then we'll need to know that information, won't we? Alright, so I'll just give myself a little bit of space in here so I can actually show you the mathematics behind what you've got to do there to actually answer that bit. Alright, so if I start thinking about the actual height, original height of this particular data is in fact 3.9862. Alright, so if we look at that, so our height, original height, so h of 0 is in fact equal to 3.9862. Alright, so the thing is, I want to find the time taken for it to get to half of that original height. So if I divide that by 2, then I'm going to get something like 1.9431 or something like that. Okay, so that would be my height. Now, if I put this into the equation, now the other thing I should show you is working this bit out here so we can get our model right. So if we work out our model, we already did that, so that's 0.7993. So I should write this model over here as equal to our height, t is equal to 3.986 to 0.7993 to the power of t. That's our model that we've actually got. So when I put this into the equation, what I'm saying is for 50%, okay, or half the original height, we're going to have 1.9431. That's equal to 3.9862 times by 0.7993 to the power of t. Right? So I need to simplify this and solve this for t, and this is the power of using logs. So what I need to do is divide this value here down the bottom line. Okay, so that's what I'm going to do. So I'm going to go 1.9431, divide that by 3.9862, and that's equal to 0.7993 to the power of t. Got the idea? Now, without actually doing any thinking, we should know that that's actually equal to 1 over 2, because that is a half of the original height. So therefore, what I can say is log of a half is going to be equal to t times by log of 0.7993. So therefore, t is equal to log of a half, all divided by log of 0.7993. Now you can work that out yourself. Now when we do the second one, as in this particular case here, remember it was a half, we're now looking for a tenth of it, so you're going to end up with a tenth, no matter what you're doing, is equal to 0.7993 to the power of t. So therefore that's going to be equal to t is going to be equal to log of 1 over 10 over log of 0.7993. So that's one way of doing it. That's the mathematical way of finding out your answer. The alternative way is to get your ruler and basically try and come down to an answer which is a little bit below 2, drawing across, right, coming across there, and then coming down. Alright, that will give you an idea whether your answer's pretty right. And again, you might come down to the bottom bit down here where it works out to be. Now the problem here is I haven't really extended that model past what it is, so it might take a bit longer to do than that. Alright, in regards to that particular example. Alright, good luck with that anyway. I hope this helps. Now, keeping in mind it's an investigation, so you need to look at doing your own thing. It's about showing off that you can do the mathematics, you can use the formulas, and that's really what you're needing to try and do. And make it as specific as possible. Try and make it precise. Don't try and do lots and lots of the same stuff, but try and do, you know, some varied, you know, things. So in terms of this first video, I think I'll leave it there, and then I'll start talking about the second question from then on. Okay, so good luck with that, and catch me either in class or at some other stage if you need some help with that.